the reading too. I'm going to go through this a little bit, but you are going to need to get your answers out of the book from the reading, which is also important. So, there's really just 3 questions, and they're not even like too bad questions. Let me open them up. Can I do a different? I thought I had it opened up in a lab here, or a different tab. There we go. So let's go ahead, and it's the constructive response is what we're doing. The reading is the formation of igneous rock, so please have that open. That will help you answer the questions correctly. So question 1, describe the 4 categories of igneous rock based on dominant mineral or element composition and provide 1 example of each type of igneous rock. So if you go back to the reading, those 4 categories that they're talking about here are going to be not in texture. They're going to be these 4 categories right here. So felsic, mafic, ultramafic, intermediate. And so really, you're looking to give them the definition that they're giving you here and 1 example of that type of rock. So for felsic, your rock type is going to be granite. For mafic, your rock type is going to be gabbro. For ultramafic, the rock is peridotite. And then intermediate, do they give you one? Yeah, they give you a rock name there. So your answer is basically these 4 bullet points for that particular question. Question number 2. Igneous rocks form in a variety of textures, including fine grain, coarse grain, and porphyritic. Explain how each of these textures forms. So we talked a little bit about that yesterday. I definitely talked about the fine grain and the coarse grain. I skipped over porphyritic just a little bit. But what we talked about is the crystals growing, right? So if it's coarse grain and it has big crystals and I can see them, then I know that the lava cooled very slowly. The heat escaped slowly, and so the crystals had a long time to grow because they got big and cooled slowly. And so that's what you're looking for that. Your coarse grain will cool slowly. Your fine grain, as it says right here, will cool relatively quickly. And so the crystals did not have a long time to grow. They cooled almost instantaneously, and so they're very, very small. And then they have another rock type. I was hoping they would have them like actually listed here. Let's see if it does down below. But it's called porphyritic. So those are the 3 that they talk about. Large grain, fine grain, and porphyritic. And I'm trying to see if they actually give you, they don't give you anything here. Vesicular texture, glassy texture. Here we go, porphyritic. Porphyritic is where I have both large and small grains. And so if a large grain rock cooled very slowly and took a long time, and a small grain rock cooled very quickly over a short period of time, then if a rock has both of those, then you know that something happened and it underwent both types of conditions. So for example, I can actually draw it over here. A porphyritic rock would start off underground as a pluton, and it would start to cool down a little bit here. And so I'd start to get some bigger crystals forming in this pluton. And then eventually erosion would happen. The ground level kind of comes down and the rock is exposed, and it cools quickly after that. So I have 2 different cooling periods, a slow cooling period, a quick cooling period, and then I get a bunch of smaller crystals all in between, which is called the matrix. And so that's what happens in porphyritic. So they want to know, what are your 3 different igneous rocks form in a variety of textures, including fine grain, coarse grain, porphyritic. Explain how each of these textures forms. So coarse grain is going to cool very, very slowly over a long period of time. Fine grain is going to cool very quickly over a short period of time. And porphyritic is going to have 2 different cooling rates. First, very, very slow. Second, very, very fast. And then igneous rocks form from material that originates in the Earth's interior. What is the difference between intrusive and extrusive igneous rocks? So we went over that yesterday. Intrusive versus extrusive. Intrusive is going to stay inside. It's going to cool very slowly as magma. Extrusive is going to exit the Earth's surface as a volcano, and that lava is going to cool very quickly. Provide 3 examples of structures made up of each type of rock. They actually have that in the reading. So, intrusive structures are going to be right down here. Let's see if they actually have them listed. Yeah, so like 3 features that are intrusive: a batholith, a pluton, a stock. They might even have dike in there. 3 intrusive or extrusive features are going to be down here. What, like a tuff, a volcanic flow. What else? Volcanic flow, a tuff, a lava plateau. Those might be the 3 there, because they didn't actually list those. So flood basalts, lava plateau, a tuff, Tuff, ash. Ash is another one. Ash layers, tuff layers, lava flows, lava basalts, plateaus, lava plateaus, any of that. So you can find the answers in the reading. It should kind of go in order. So first question, you're answering right here, classifying igneous rocks. Second question, you're answering right here in textures. And then third question, you're answering down here in plutons and then in extrusive structures. So if you have any questions, let me know. Make sure you hit submit when you get done typing in your answers. And that will be our little assignment for today. Lights coming on. Anybody have any questions? Wonderful.